I looked around to find this one. We've got a piston cylinder apparatus, and it's filled up with XY gas. Okay. Do you not have this page? You don't have? Okay. Well, real quick, make a sketch. Piston cylinder apparatus with the cylinder halfway up, a little less than halfway up. And the temperature minus 73 degrees Celsius. Okay? And the question says the gaseous reaction in the piston cylinders depicted below is carried out at constant pressure. Okay, that's point number 1. At P atmosphere is the same on both of them. Okay, constant pressure. And minus 73 degrees Celsius at the beginning. So T1, lowercase t1 here is minus 73, okay, degrees Celsius. And the equation shows you what happens when we go from condition number 1 to condition number 2. A chemical reaction happens. XY goes to X2 plus Y2. Well, wait a minute, that's not balanced. Let's put a 2 in here. Now it's balanced. And that's important because we need to know whether the number of moles changes during this process. Because look what the question asks us. What's the final temperature? There's a change, so we're going to have to use the combined gas law, right? We're going to have to use that. And by inspection here, I'm looking at this, and this, and I'm going to say V2 is about equal to 2 times V1 by eyeball, okay, my eyeball. V2 is about equal to 2 times V1. And, of course, P1 is pressure of the atmosphere is equal to P2 equals P atmosphere. And the number of moles doesn't change because this is 2xy, 2 moles, and this is x2 plus y2, which is 2 moles as well. So N1 equals N2 in this process. So P1, V1 for N1, T1 is equal to P2, V2 over N2, T2. And we're going to solve for T2. But now we're going to notice P1 and P2 are the same. And N1 and N2 are the same. So this little thing simplifies down to V1 over T1 equals V2 over T2. But we said up here the V2 is about equal to 2 times V1. So if we put 2 times V1 in this, then the V1s cancel, and we have 1 over T2 equals, 1 over T1 equals, let's write it out. V1 over T1 is equal to 2 times V1 over T2. Okay? So T2 over T1 is equal to 2. All right? So all we have to do to solve this is convert this to Kelvin temperatures. So T1 is equal to minus 73 plus 273. That's 200 kelvins. So T2 is going to be equal to 2 times that, or 400 kelvins. And it wants it in degrees Celsius, not degrees Kelvin, or kelvins. So this is 400 is equal to T2 plus 273. And if we solve that for lowercase t2, that is 127 degrees Celsius.